Now we'll proceed to handle more of these typecasting. So let's say you have something which is basically saved as text. So when you import something from Excel or when you import something from a database, it might actually be having some values which are numbers, but they come as text. This happens most of the time because it's a structure with which you save it in the database. So let's say the data, not a good idea to use this because this is a inbuilt name. So let's use something like integer saved as text. Right, sure, you can do that with something like as you can say to as dot factor, wherein you might say that okay, let this numbers actually be numbers say 30 or 31 to 40. This is what we are artificially simulating some data. Now if you check this object, you will see it's shown up as integer saved as text, right? And if you say what is the class of this data type, it would be integer saved as text. It says it's a factor. Basically a factor is nothing but something which is defined for the R internal system as a class based object. Class might be ordinal, class might be nominal also, right? Assuming we don't have any idea as to what is the form of this data, let's see what happens if we just try to convert this or typecast this into something which is integer, because that is how you actually wanted this to be used. So let me say I am saying new integer, that's how I want to save it. So I am saying a typecast operator as numeric, right? Now I pass this object that is saved as text as new int, right? Now if I check what is the content of this, it will show me a 1 2 3 to 10 and not show me the actual value of this 31 to 40. So if you go over here, you might see that this is how it is stored, right? This is how it is stored. But if I go back to the original object over here, so int saved as text, so this will actually show me the data 31, 32, 33 and all these things. But the problem comes when I try to apply some functionality. Say I want to compute the mean value of int save text. This will give me an error. Why? Because this object, this data type is basically a factor, and you cannot apply basic arithmetic on factors. You can do something like frequency binning on this type of data. So obviously, but I am interested in this value now, right? And that's a necessity for me to typecast this in a better way, and pragmatic thing is to understand how these things actually move inside. So now I would say that what is the option to move it or how to typecast this? So the internal working is that you have to first convert it into a character. So you should first typecast it into a character form and then you typecast it into integer form. So let's redo this whole exercise again. So I'm just using the up arrow key to bring the same thing which we did over here, but instead of directly converting it into numeric, I first say as you have it to care functionality. As dot character. So first you are going to convert this factor data type into character, and then you are going to convert it into numeric form. So now what we'll do is we'll understand how to use a transformation on this data. So we are going to typecast obviously, but we are going to make sure that we don't lose the data over here. As you saw, we were losing that context because the factor location was coming or the internal factor name was coming, but the actual data was lost. So what we will do is we will now do the typecasting. So let me say new int, that's how I'm going to save it now, allocation sign. So I'm first going to say as dot character, and int saved as text would first go like this, and over this one I am having a wrapper function as dot numeric so yeah, we're going to wrap it over here. Now if you have a look over here, you will get the actual data which you were missing. In the previous case you were seeing it only as 1 2 3 till 10, and now it's actually giving you the correct data. So this would be one of the transformations wherein you are using typecasting to convert your data from a factor to first a character type, and then from the character type you're converting that into the numerical form which you actually intend to have. But for most of the cases in practical application, you will see that you will be working more on factors rather than base integer vectors most of the time. To go a bit further into this, let's say you are doing some kind of transformation, some of the functionalities, say you are using an if-else statement. You have to understand that some inbuilt function returns the data in a specific data type. So let me say the same new int over here, right? If I want to do some kind of operation over here, let me compare it with a value called as 34. So if I use an inbuilt function like if else and say if else new int, and I say if it is greater than or equal to 34, I want this to be saved something as high, value high, text value, and or else I want to be saved this whole thing as low, and I want to actually push this as a data frame. Let's call this as typecast text. Now you will see that this is 10 observations of a single variable. Okay, obviously this has happened because we have not given a name to the column in the beginning, which incidentally we can give if we want. So we can just repeat this whole thing again, and we can give a good fancy name. So we can say transformed variable. Let's put something like this. Okay, it's not accepting it in this form. So what we can do is we can just use the call names functionality and just make it simple to. So let me say this is say rule transformed. So my data will start looking like now. If you check the data type of this class, so let me access this. So this would be typecast text. If I check the class, this should be a data frame. That's how we have saved it. If you go further and you try to access this, saying it's class for the individual column is a factor over here. Now this is happening because you have manually done this. Supposingly if you are importing data from some web-based application, or you are importing it from an existing CSV file, in that case, if you have not initialized that to a factor, it will come as a character string. Obviously you will have to do transformations in this case if you don't want it to be in this form. So I might want this to be saved in a different form also sometimes. So if I am doing text mining, I might be interested to save this not as factor but as text. So I might do a reverse typecasting over here, because here I want this to be seen as text. Maybe I'm doing some text analytics, say for example. So I might say typecast text, accessing that. I don't want it in a factor form, I actually want it in a text form. So I might say as dot character, and pass the whole thing again, access it, and then I can check the class. So it's character. So sometimes I might want data to be in the factor form for doing modeling, but if I'm doing text mining, I might want it to be in the form of a character or string or something like that. So these would be typical ways in which you can typecast data from one frame into another depending upon your requirement. Now say for example, if you're working on a matrix, so let's artificially create a matrix. I'm just closing this part and I'm saying Control L just to clean the screen, and let me clean all these objects also because there's too much of things in the memory. Okay, so it's plain whiteboard again. So let me say I'm creating a new matrix, naming it as new matrix. I'm saying matrix. Okay, I'm saying that the data, you can refer to the internal working like this, wherein you can give the prefix so that it becomes easy for you to relate. And I'm saying let this be a sequence of numbers, say 1 to 50, that is my data. Okay, and I want to say that I want the number of rows to be say 10, and obviously the column has to be in that case 5, 10 by 5, and I want to say that let us arrange the data by rows and not by columns. So in this case I'm going against that and I'm saying this is true, so it will be sorted in this way. So 1 2 3 4, it will come in this way. So this is how I save my data. So that's how it is coming. Had I done it in this way, wherein I would have said this is false, my data would have come like this. So it would have been arranged in this sequence. Okay, whatever the sequence is, my intention over here is to now show that, okay, if I add something to this data, like some text or some other data type, that is where the problem arises. So let's say I have a sequence of one column which has something like names, right? So let me say new matrix. Trying to access this, so I'm saying let me access or let me create first a vector. So let me create a vector of names, wherein I'm saying let's have something like this. So I need a few names, so 10 names. So I'm using my name only and I'm just giving some prefix. Okay, say 1, 2, or you can use something like this also, where you can say replicate, say Mohan, 10 times. Let's make it a little bit different, and let's say suffix, saying replicate, or let me just add sequence of numbers over here. So I'm saying 1 to 10 just to make it easy, and then I'm saying combine names. Like name. Okay, select names. So you can see this object. Oh, we don't need this. So what I'm going to do is I'm just going to put the first one, like names. Okay, this I'm going to just push in this object new matrix. So new matrix is nothing but new matrix, the existing one, and say use let see how it works. Okay, so this is what we have got, but what has actually happened with this data is, if you see this typecast over here, it has automatically changed into a text form of data, which you don't expect because you want to do some computations on this data, right? And this is the problem when you're working with different types of data and you're trying to use a matrix. So in this case, you might actually prefer to work on a data frame, and that is what we'll be doing as we go next. So let me go on the internet and grab some data file, or else we can do one thing. If we have a package already installed, we can download the data from there. So let's check if we can use this data. Okay, so there's a package called as mass, in which you would be having a data called as Boston housing data set. So I've just loaded that data set into my memory, and then you can just have a look at this data. So this is our data. So it has something called as a crime rate. So obviously we are not going to get into the detail as in a case study, but let's use this data frame itself to do some typecasting within the existing data. So say for instance, I am intending to first understand what is the names over here. Right, so this is how the data is. If you want to get a brief idea as to what these names actually mean, you can just do a double click over here, and sorry about that, okay, and do that. It will show you this link over here, right? And then you can just get into this help file and see that, okay, this is the data, 506 observations, 14 column data. It's in the data frame format, and each of these variables, their definition versus the data definition file. You see, crime is per capita crime rate by town. ZN is proportion of residential land zone for lots over 25,000 square feet. Indus is proportion of non-retail business acres per town. Non-retail business, that means it's basically something like close to office space. Indus is proportion of non-retail business acres. In this case, it is industrialized areas. So you can read through this file to get a better idea about this data. What I can see over here is there is a variable called as MEDV, which is median value of owner occupied homes in dollar terms. So if you can see, it is 5 over here. Say minimum value is 5. That means it is $5,000. Right? That's how you will relate. Now supposingly I am interested in typecasting this specific column in my data frame Boston into something which is called as high, low and medium, right? That's the segregation I want, right? Because that is my intention to analyze the data in that way. I don't want to see it in a numerical form, but I want to see it in a categorical form, say for example, which incidentally is represented as a factor. So I can do something like this, which we have already done, and I'm going to create a new variable just so that we can simultaneously compare this also. So we can say Boston dollar MEDV in class form, that is categorical form, and I'm saying use an if else statement wherein you keep saying Boston dollar MEDV, checking whether if it is greater than or equal to something. So let me give only two classes. So I'm saying if MEDV is greater than 25, so I'm going by the basic statistical rule that anything above the third quartile is a really high value, right? So I'm saying anything which is equal to or greater than the third quartile, so I'm saying that value is taking as 25, then you mark it as high price of property, or else you are saying it's low price. You can have more than two classes, but the intention over here is just to understand typecasting and not actually understand how an if else function works. So we're doing that. Now if you do the summary of this data frame, so that's Boston. Okay, now what I'm seeing over here is that this data is represented in character form, but what you actually want this to be represented as is factor form. So again, you need to typecast this data within a data frame. It's not a vector, so it's because if you had seen the previous case when we had used an if else in a vector form of data, when you are using an if else statement, you're using something like this also, and you use a cbind statement, it gets merged into the object as a factor. But the same data or something on similar lines, if you're doing the functionality on a data frame, the returning type is not a factor, but it's a character vector. So obviously you'll have to typecast this again. So we could do something like this. So I'm saying Boston, I'm overwriting this again. So I'm using the MEDB class object, and I'm saying over here as dot factor, and then I say Boston dollar MEDB class, just doing a typecast on a data frame, specifically of a column within a data frame. And then if you look at the summary, it starts showing you your data in basically frequency based bins, and that is what you really want. So depending upon your requirement, sometimes you have to typecast the data from one form to the another form to make sure that the algorithm which you want to run over there makes sense. So you might be interested in doing something like a logistic regression model over here, and the data has to be in this binary form, and that's why you might have to do this transformation. So let's say I want to do something else. So let me say like I have something like a crime value over here, right? And I want to basically bin this first. Now when I'm working on numerical values, right, and then I want to again convert it into this type of data, that is categorical form, but obviously over here I don't just want one category, but I want multiple things. So I can do something like this. I can say Boston dollar, I'm creating a new, or let me give it as CRIM underscore class, right? So I'm not doing it in one shot, I'm doing it in stages. So let's now try to bin this into some small buckets of data. So you can basically use a functionality like cut, where you can say Boston dollar, say crime. You can specify the number of breaks which you expect in the data. Say you're not getting into the summarized form of data, analyzing the data much, but supposingly I want to group this into say 10 buckets. You have other options also which you can specify, but in this case we are just ignoring that. So you have created a new variable over here. If you do a summary of Boston now, it will show up like this. So you can see this very same data crime, you have binned it in this form, right? That's how it's coming, right? So you might call this as a low crime class and this as a high crime class, right? If you want to use the same names over here, you might just directly convert this or rename this into some other form. Let me see what are the unique options available over here. So unique Boston dollar crime, I'm saying class. So you have these distinct groups over here, which incidentally you can rename by identifying using an if else loop and just make some changes over here if you are interested. So this is how you might want to convert data from a continuous form, so typecast it from a continuous form into a class based data that is a continuous form also. So depending upon our application, our requirement, we might intend to do lots of transformations on the data, typecasting, binning and all those things. So that's how we do.